Hey, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And as the title of the video suggests, today's topic is the rules and pseudocode of prefix to postfix conversion using stack data structure. So in this tutorial, we are going to see the rules and the pseudocode that is used to convert a prefix expression to a postfix expression using stack data structure. Now before we continue forward, if you've missed any of the previous tutorials in this playlist, where we've discussed everything about infix, prefix, postfix, the different manual conversions between all these three different expressions and why do we need them. We've also discussed about postfix to prefix using stack, that is the vice versa process, and all the other different conversions have already been covered in this playlist. So if you've missed any of the tutorials, please do check out this entire playlist, entire course. I'll drop the link in the video description. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks, and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so as you can see on the screen on the left hand side, we have certain rules for prefix to postfix conversion. But before we get on with the rules as well as the pseudocode, in the center you can see I have given a question which is a prefix expression which we have to convert to postfix, but in brackets it is saying manual method. Now in previous tutorials we've also discussed the manual conversion of prefix to postfix and vice versa process. So I have this entire long prefix expression which we will convert manually to postfix, and on the right hand side we have the same question. You can see it is the very same question where we have a prefix expression and we have to convert it to postfix expression, but this time it would be done using stack data structure. So what we'll do, we'll solve this. I'll quickly show you the solution because we've already learned how to do the manual conversion. We'll take this solution and we'll write it over here, and then we will again apply the rules as well as the pseudocode on this same expression, but this time we will use stack and we will get the result using stack, and we will compare the two answers to verify whether our conversion is happening correctly using these rules as well as the pseudocode. Okay, so let me just quickly show you the manual conversion of prefix to postfix. Okay, so this is the question, and as we move forward, what we do, we go from left to right. We take the first instance of one operator and two operands and then convert it to its appropriate postfix format. So plus AB becomes AB plus. That's why I've written it in pink. Okay, so pink represents postfix, yellow represents prefix. Then we take AB plus and we assume it as x1, so AB plus becomes x1, and then we again continue this process throughout this entire prefix expression until everything is converted to its postfix format. So that's how things go, and we've already discussed all this, so I'm assuming you guys already know. So we're not gonna waste time. You can pause the screen and go through the entire conversion, but ultimately this is the result that we get, which is basically a postfix format of this prefix expression. Okay, so we are going to write this over here because it is the result of the manual conversion. So there you go, I've written it over here. And now let's see the pseudocode, because now we will apply the rules as well as the pseudocode onto this same question which is written over here as well. But this time we are going to use the stack data structure to make this conversion happen from prefix to postfix. Okay, so as you see in the center we have the pseudocode of prefix to postfix conversion using stack data structure. And on the left hand side we have the corresponding rules. So the rules and the pseudocode are pretty much the same thing, just represented in two different formats, two different ways. And the reason why we have two different ways is because when you're just writing the working, if you're explaining the working, you can go ahead with the rules. But when you want to write a C++ program or any other program, a pseudocode is much more easier to understand and easier to convert into a program. So this is the part 1, right? In part 2, in the next video, we will take this pseudocode and write a C++ program to make this conversion happen, to take a prefix string and convert it to a postfix string. And basically this pseudocode is language agnostic, which means that it is not restricted to one particular programming language. You can use any other general purpose programming language. The pseudocode is going to be the same. Okay, because it is not exactly syntax, it is just a representation, part syntax, part English kind of terminology with proper steps, which can be easily converted into any programming language. Okay, so I'm quickly going to go through the entire pseudocode and its corresponding rules, and we will read through them for the first go, and the next time we will apply it onto our example, because in the first go it might not make complete sense, But once we start applying it onto our example, onto our prefix string, things will be very much clear. Okay. So starting off with the pseudocode, we create a function called prefix to postfix and we pass the prefix string. Okay. The step number 1 is to create a stack data structure, a stack object. So programmatically, we will create a stack. You can consider this as the stack. So second step in the pseudocode is to iterate from prefix.length -1 to 0, which means that we are going to go in the reverse order. Now this instruction or this step is corresponding to rule number 1 in the rules of prefix to postfix, which says can the prefix expression from right to left, that is in reverse. Now this is that prefix expression. So if you observe it programmatically, it would be a string variable, right? It would basically be a string. So that string will obviously have index places, and at the 0 index place we will have the very first symbol, which is a divide sign. Then at index position 1 we will have star. And what this rule essentially is saying, rule number 1 and the loop is saying that we have to loop in the reverse order starting from right to left, that is in this direction. Okay. So over here, what is the length of this prefix string? You can see we are going from 0 to 12, which means that the length is 13. So 13 minus 1 is equal to 12, and we have to go till 0. So starting from index position 12 to index position 0 is where we have to traverse, okay, in reverse order. So this is the loop and the corresponding rule for this loop. Now inside this loop, that is inside step number 2, we have two basic conditions or two major if-else conditions. The first condition 2.1 says if prefix of I is an operand, then we have to push this operand, that is push this prefix of I onto the stack. So s.push. So if 2.1 is true, we have to go in 2.1.1 and push it onto the stack. So 2.1 corresponds to rule number 2, which says if the incoming symbol is an operand, push it onto the stack. Simple. And the second condition says else if prefix of I is an operator, operator is plus, minus, star, divide by and a raise to sign. We are considering these 5 symbols as operators. In that case, what we have to do, let me read out the rule. If the incoming symbol is an operator, we have to pop 2 operands from the stack. So at 2.2.1 we say s.top, that is take the top of the stack and store it in operand 1. Then we pop it out, that is we remove it out. Then we take second operand, again s.top, we store it in op2. So that is what this line is saying. If incoming symbol is an operator, pop 2 operands from the stack. Then we say add the incoming operator at the end of the 2 operands. So at 2.2.5 we create a expression, we say operand 1, operand 2 and then the operator at the end. So this is basically a sub postfix expression that we are creating. And lastly we push this whole new expression string back into the stack. So at 2.2.6 we push it onto the stack, we are saying s.push. Okay. So this is basically 2 different conditions that are there in the loop. After this loop we say end loop, and the last instruction is corresponding to rule number 4, which says at the end pop and print the full postfix expression from the stack, which basically is return the top of the stack. Now if you are wondering why do we have only 2 conditions, it is because in prefix and postfix, remember we do not have any brackets. So only 2 possibilities is either the symbol is going to be an operator, operator is as I mentioned plus, minus, divide by, star and a raise to sign. So only 5 possibilities for an operator, or it can be an operand. An operand can be A, B, C, that is the variables in small caps, large caps, or it can be composite operands, which is A plus B together can be considered as an operand. In the case of prefix, it would be plus AB, which can collectively be considered as one operand, or it can be any constant. In our case, it is going to be individual variables A, B, C and composite variables plus AB, and you'll understand that as we move ahead. So these can be operands and these can be operators, and that's why we only have 2 conditions, one if and one else if. When we write the code, it would be if and else, because if it is not an operand, the only other possibility is going to be operator. But I have denoted else if over here to make you understand that the second possibility is an operator. But anyways, this is how the pseudocode goes and this is how the rules apply. And if you've seen the previous tutorial where we discussed the reverse process, that is we saw the rules and pseudocode of postfix to prefix, the pseudocode and the rules were pretty much the same, just that in postfix to prefix we loop from 0 to length, that is 0 to postfix.length -1, and the expression that we created which was supposed to be pushed onto the stack was different. Over there it was postfix of I plus op2 plus op1. Okay. And now because we are going in reverse order, we have to do op1, op2 and plus prefix of I, thus creating the sub postfix expression. And I know right now me just talking is not making a whole lot of sense. So let's take this pseudocode, let's take these rules and apply it onto our example now. Okay, so let's start off with the first instruction in the pseudocode. We create a stack. Let's assume this is the stack. You can see this entire bucket. Step number 2, we have to loop from I equals to prefix of length minus 1. What is the length of this prefix string? It is 13. 13 minus 1 is 12. We will go from 12 to 0. So initially index position I is gonna be equal to 12. Let's keep a track of index position I over here. Now we go inside this and we are at the last index position, which is basically G, and it is an operand. So inside this loop we check 2.1. If prefix of I, that is if prefix of 12, is it an operand? Yes. G is an operand, right? It is not an operator. So in that case we will execute 2.1.1 and we push it onto the stack. That is this rule number 2, that is if incoming symbol is an operand, push it onto the stack. So let's write G over here. I'm gonna use pink color for operands and green color for operators. Okay, so I entered G into the stack and now this becomes the top of the stack. Okay, that's how stack data structure works, right? We've already discussed how a stack data structure works. We've also implemented a stack in this data structures and algorithms course. So if you don't know what that is, definitely check that video out. It is important. And anyways, since this if block, that is since this 2.1 got executed, obviously 2.2 will not be executed. That's how if else works. So if it is an operand, it is not going to be an operator. So 2.2 does not execute. So we will come at the end of the loop. We will go at the start of the loop and I will become minus minus because now we will move in the reverse order. So I will become 11. So now we are at this index position, which is F. So F is also again an operand. So again, condition 2.1 will be applied. F will be pushed onto the stack. And similarly, if you observe, after F we have E. So E will also be pushed onto the stack. In all the cases, 2.1 is applied. So let's add them to the stack quickly. Okay, so we've added F and E onto the stack. And when we are at E, the index position is 10. So I is going to be 10. And now we will again go one index less. So now I becomes 9. So we are at this index position. Alright, so now things are going to change because now we have an operator. So first, obviously, we will check if prefix of I is an operand. No. In this case, it is a raise to sign. Raise to sign is an operator. So 2.1 will not be executed. We will go to 2.2. So 2.2, we check if prefix of I is an operator. It is a raise to sign, which is yes, it is an operator. So in this case now, the rule number 3 is going to be applied, that is 2.2, which means 2.2.1, 2.2.2, 2.2.3, 2.2.4, 2.2.5 and 2.2.6. So let's start off with 2.2.1. We say op1 is equal to s.top. So let's create op1 equals to s.top. S is the stack object and top means whatever is there at the top of the stack. What is there at the top of the stack? It is E. So I'm gonna say op1 is equal to top of the stack, which is E. So op1 equals to E. Then we move forward, we say s.pop, which means we remove this top of the stack, which is E right now. So when I remove the top of the stack, this gets erased out. And now the new top of the stack is F. Then we move on to 2.2.3. We say op2 is equal to s.top. What is the new top of the stack? It is F. So op2 is equal to F. Okay. Then we move on to 2.2.4. We say again s.pop, which means we remove out the top of the stack. So now the top of the stack is G. After this we say 2.2.5, which says exp. So we create a exp expression equals to op1. What is op1? op1 is E. Then we say plus op2. So we are concatenating or appending op2 over here. What is op2? op2 is F plus prefix of I. So we are currently at index position 9, which is a raise to sign. So prefix of I is a raise to sign that has to get appended over here. So we'll append that over here. And this is the sub postfix expression that we've created from this prefix expression. So it was raised to EF, but we created EF raised to. So prefix expression got converted to postfix format. And lastly, we will come to 2.2.6 and we will say s.push this expression onto the stack. So we will take this expression exp and we will push it onto the stack as it is. Okay. So now this becomes the new top of the stack. Okay. So after 2.2.6, we complete the else if part, that is complete the 2.2 part. We come at the end of the loop. I now becomes 8. So we are at this index position, which is D. D is an operand. We simply push it onto the stack. I'll write D over here. This becomes the new top of the stack. Okay, so now I becomes 7. 7 is again a raise to sign, which is a operator. So obviously 2.2 will be executed and not 2.1. So we will again create OP1. OP1 equals to top of the stack, that is 2.2.1, which is D right now. Then we say 2.2.2 s.pop. So we remove this top of the stack. The new top of the stack is this sub postfix expression, which we take in OP2 at 2.2.3. We say s.top. So OP2 equals to this EF raised to sub postfix expression, right? Then at 2.2.4 we say s.pop. So we remove this top of the stack as well. So now the top of the stack is G. Then at 2.2.5 we create this expression exp equals to OP1, which is D. Then we append OP2, which is EF raised to, and then we append prefix of I. What is prefix of I? Prefix of I is yet another raised to symbol, because we are at index position 7, which is another raised to symbol. So I'm simply gonna write that symbol over here, and this, my friends, is the new exp expression, which at 2.2.6 we will push onto the stack, and then this becomes the new top of the stack. Okay, so I hope you're understanding so far. We are at index position 7, and then after 2.2 is executed, we will again come at the start of the loop. I will become 6. Now if you observe, 6, 5 and 4 are all operands, so they will get added onto the stack one by one, because all of them are operands. So when I become 6, we will be at C. C will be pushed onto the stack. Then I will become 5, which is B. B will be pushed onto the stack. Then we have A. Again, A will be pushed onto the stack. So let's not waste too much time over here. So the top of the stack is A now. And then I will become 3. When I becomes 3, we have plus. Now plus is obviously an operator, so 2.2 will be executed. We will again say OP1 at 2.2.1. OP1 is equal to s.top, which is A right now. Top of the stack is A. Then at 2.2.2 we remove the top of the stack. Then at 2.2.3 we say OP2 equals to s.top, which is B. Then at 2.2.4 we remove that B also, saying s.pop. Then we create exp. Exp is equal to, we say OP1, which is A. We append OP2, which is B. And we say prefix of I. Prefix of I is this plus operator, because we are at index position 3. So we'll write plus over here. And then we take this expression at instruction 2.2.6 and push it onto the stack. And this becomes the new top of the stack. Okay, so again now I becomes 2, and we have yet another operator. So at I equals to 2 we have minus. So again 2.2 will be executed. We will say OP1 equals to, what is OP1? Top of the stack, which is AB plus. So that would be OP1. Then we will pop this top of the stack at 2.2.2. Then we will say OP2 equals to top of the stack, which is C. Then we will obviously pop the top of the stack again at 2.2.4. So C is popped off. Then we create this expression exp, which is gonna be OP1, which is AB plus. Then we have OP2, which is C. And then we have prefix of I. What is prefix of I right now? We are at index position 2. So prefix of I is a minus operator. So I'm gonna write minus over here. And this sub postfix expression is what we will push onto the stack at 2.2.6. And this is gonna be the new top of the stack. Okay. So now obviously 2.2 is done. We will come at index position 1. That is this index position. Again it is an operator, it is a star operator, so 2.2 will be executed. So inside this 2.2.1 we'll say OP1 equals to top of the stack. What is top of the stack? This AB plus C minus. Let me write it in a compressed way. So AB plus C minus is op1. Then we will pop the top of the stack at 2.2.2, so this is removed. Then we also have op2, so op2 is equal to def and raised to. So again we will pop this top of the stack as well at 2.2.4, and at 2.2.5 we will create a new expression exp equals to, we will take op1. What is op1? op1 is ab plus c minus, then we append op2. What is op2? op2 is def, then we have raised to, and then we have last prefix of I. What is prefix of I? Prefix of I is this star symbol. And now guys, we will take this entire sub postfix expression. I'm saying sub because we are still not completed the entire iteration of the prefix string. We will take this and push it onto the stack at the instruction 2.2.6, and now this becomes the new top of the stack. Okay, so now we will say I minus minus, so I will now become 0, which is basically the very first in the prefix string and the last symbol that we have to iterate. So I becomes 0, after which the loop will stop. But again the last symbol is also an operator, so again 2.2 will be executed. So we will say op1 equals to this entire top of the stack, which is this entire string. So op1 equals to this. Then at 2.2.2 we will pop it out. Then at 2.2.3 we will say op2 equals to top of the stack. What is top of the stack? It is simple operand g. Then we will say s.pop at 2.2.4, so the stack becomes empty now. And at 2.2.5 we create this expression exp equals to, which says op1. So let me paste op1. So I've pasted op1, which is this entire postfix string. Then we have to append op2. op2 is simple g and plus prefix of I, which is this last symbol, which is divide by. So don't forget to write that also. So I'm gonna write divide by over here. And then at 2.2.6 we will take this entire postfix string and we will push it onto the stack, and now this becomes the top of the stack. Okay, so after this I is 0. After this we don't have any other symbol to iterate, so obviously this loop will break and we will come outside this loop, and the last instruction is return the top of the stack. So what is the top of the stack? If you observe, this is this entire postfix string, and this, my friends, is actually the final answer. So let me just paste this string over here also at the result of using stacks, and just observe this manual conversion result and the result that we got using stack, using this pseudocode and using this rules. We have AB plus C. So we have AB plus C. Then we have minus DEF. We have minus DEF. Then we have raised to. We have raised to. Then we have star G and divide by. So that is also same, star G divide by. And this basically concludes that our function, our pseudocode as well as our rules to convert a prefix expression to postfix expression using stack data structure is working exactly fine, exactly correct. And you can take any other simple prefix string and apply this pseudocode as well as this rules, and you'll get the same result. Compare it with the manual conversion and I'm sure you're gonna get the same result. We took a lengthy example so that we get the best practice, but I hope now you have understood the entire rule as well as the pseudocode of converting a prefix expression to a postfix expression using stack data structure. So now that you've understood this rules as well as pseudocode, please do give this video a like, definitely share it with your friends. Let me know in the comments how this video was. In the next tutorial, we will take this pseudocode and write a C++ program to convert a prefix string to its postfix format using stack data structure. So that's the practical aspect of this topic. So don't miss that video as well. And this is where I'm going to conclude this video. Thanks for watching. See you in the next one. Peace.